Okay, the first demo I think you should do, which I think follows naturally from, materials are everywhere, is the processing structure property demo using hairpins. So these are hairpins. I got them from Walmart. They were like, $2 for 100 of them. You need hairpins. You probably need maybe 4 of them. You can have more. You can pass them out. It's really great that the students can touch these, because if you touch it, you really get an idea of what's happening. So you need a handful of hairpins, a glass of water, needle nose pliers, because we're going to take these and we're going to put them into a torch. The great thing about the hairpins is they cool off really fast. Make sure you don't take it out of the fire and hand it to someone, but just wave it around in the air and it'd be cool enough that you can pass it around. And safety glasses. Ready. So what's the basis of materials engineering? What's it all about? Well, it's about relating the structure of a material to how it's processed and the final properties. And you think, well, what's structure? Well, structure is actually really broad. I mean, you think about structure, you have something simple, like you've got, the shape of a pair of pliers, right? But this pair of pliers is made out of a metal, and the metal had to be processed to make it this shape. But the metal itself also is processed, and that's because inside this metal, there's lots of little crystals. And these crystals are around 1/2 the size of a human hair. Very, very small. And we use microscopic methods to examine them and to know their structure and how they impact the properties. But inside those crystals, we have atoms, so we have atomic structure, and that can be changed by changing the composition, right? So this probably has, definitely has iron. It's got maybe some carbon, molybdenum, a bunch of other trace metals, and those were all selected because that changes the crystal structure. So macrostructure, the microstructure, how the crystals arrange themselves, the atomic structure, what goes into it, and then down on the smallest end are the electronic structure, how the electrons move around. And materials engineers work at all these length scales, from electrons all the way up to, car doors. But I want to talk today about microstructure, because I think that really is, our central contribution. And it's also, if you think about it, it's what makes materials engineers so different from, macro scale, which I would say is really kind of in the regime of the mechanical engineers, and atomic, which is more chemical. So I'm going to show you this. These are hairpins, right? I got these at Walmart. They're like, 1 cent a piece. They all came in a big multi-pack, and in fact, they're all identical. They came off the machine at the same time. And see, they've got this really nice springy property. And the way they were formed is there was some wire, and some machine went along and went crunch, 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 and it dropped them out, and there's some type of plastic coating on them. So if I take one of these and I try to pull it apart, it's really tough. See, it's hard to pull this apart. That little bit right there, it does not want to deform. What I'm going to do, though, is I'm going to show you that I can change this with fire. By the way, materials engineers love fire. So it's a good field if you're a little bit of a pyro. So I'm getting this hot, and you see I'm getting it red hot. I burnt off all that polymer coating, and now I'm going to take it and I'm going to quench it in water. Okay, so that's cool. And now, see if I take this and I pull it apart, it breaks. I didn't burn through the metal, it didn't melt. It's just become brittle. So originally it was elastic, now it's brittle. Exact same composition. It came off the same assembly line. Well, let's try that again. Let's try that again. And now I'm going to take it and I'm going to heat it up. Again, red hot. Quench it. Okay, cool to the touch. And now I'm going to take it and I'm just going to wave it through the flame a little bit. I'm not getting it red hot, I'm just getting it a little bit warm. And I'm going to let it air cool. Hot. Don't do that in the demo. You should practice this. Okay. So, there I got it. Now watch this. Look at that, it bends. So, as formed, extremely elastic. Heating up and quenching it, it's brittle. Heating it up, quenching it, and then slowly heating it just a little bit, it becomes plastic. Exact same composition. Different structure. The difference in all these is how the crystals are arranged in the part. So materials engineers, some of us do work down dealing with, chemistry and dealing with electrons, and some of us do work up on machines that, crunch together parts. But the thing that's really cool, and what attracted me to materials engineering when I first came to Washington State University, sell it, was that I can take the exact same chemicals and just arrange them differently by controlling the structure. So materials engineers, we're about structure and understanding how processing through fire affects the structure that affects the properties.